Hi, I am Mali, and welcome to the channel. You know, taking a sketch and using generative AI to create an image is easy with ControlNet. But taking any image, AI, or an actual photo, and reversing it to a line art is extremely difficult. Take this image, for example. It's complicated. If I had to do a rough sketch, it would be something like this. Look at this interior bedroom. It's inspired by a kinetic wall design and the Fibonacci sequence. But with my workflow, it takes me a few seconds to do this. Not only that, but I can take this AI-generated comic and first remove the background. Then convert it to a line art. Let me show you how I do this and some hacks in ComfyUI for stable diffusion. Before I start, let me tell you that this is a very advanced workflow tutorial. The JSON file will be available for paid YouTube channel members. However, I strongly recommend that you watch the video, as it is crucial to understand the workflow. There are a lot of tips and tricks used that might be useful in other workflows and are not exclusive to line art. If you are new, you really need to understand the basics of ComfyUI along with ControlNet. My colleague and I have made some extensive tutorials regarding Comfy under the Stable Diffusion playlist. Please go check them out. This tutorial was requested by a user on the channel. The workflow is entirely custom and very robust. I have tested hundreds of images from various categories, and it works. Feel free to ask any questions you may have. I would be more than happy to help you get this workflow running. All the relevant links will be in the description. I will start with the essential requirements that you need for this tutorial. Afterward, I will move on to placing the nodes, explaining a little bit about why I am using them, and then I will connect the nodes and show you the workflow process. Finally, I will end up with some practical examples and difficulties you may encounter and how to use the workflow effectively to achieve the desired result. In the Comfy Manager, go to Install Custom Nodes. Search and install the following custom nodes if you don't have them. The ControlNet Auxiliary Preprocessors. This is required for ControlNet. The WAS Node Suite. I use it quite extensively. I used some of the nodes from Python GOS custom scripts. Then, you will need the Ultimate SD Upscale for upscaling. Along with ControlNet, I have used the IP adapter models. Comfy Math, but I have just used one node from it. I used it to calculate the SDXL resolution. The SDXL prompt styler. I will be using the line art style from here. However, this is very handy for applying other styles to SDXL workflows as well. You will also need to install custom models from the manager and download some manually. Install the SDXL base and VAE Safe Tensor models. Also install the SDXL Clip Vision model needed for the IP adapter. One of the nodes used is the Blip image analyzer. When you queue the prompt for the first time, it should automatically create a folder called Blip in Models. It then automatically downloads a 1.96 GB file in the subfolder checkpoint. If for some reason you do not see this file, then you can manually download it. Go to the Custom folder. Inside the WAS node folder, right-click on the config.json file and open it in Notepad. Download the PTH file from this link and put it in the following folder. I also used a node called Image Remove Background. If the node is used for the first time, it should automatically create a new folder in Models and download this on Next file. You need to download the official ControlNet Lora models. This was covered in the ComfyControl Lora tutorial video. I will be using the rank 256 canny and depth models. These models go in the following folder. I will be using one custom upscaler model, which is called 4x Full Hardy Remakri. Download and put it in the following folder. You will need one IP adapter SDXL safe tensor model. Download the file in the following folder. If any of the mentioned folders are missing, create them and put the files respectively. Based on the feedback from the last ComfyUI video, I have improved and organized the workflow. I would be grouping and coloring sections. Let's start by adding the basic checkpoint load and the VAE nodes. Use the SDXL 1.0 checkpoint and VAE here. Let's name this group as models. Now, I will be adding the image and resolution nodes. Start by adding a load image node. In Math, under Graphics, select the nearest SDXL resolution node. Basically, this node is used to get the size of the loaded image. It doesn't matter what ratio the image is. The node will get the width and height of the loaded image and pass it on to the IP adapter and ControlNet. Double-click and search for the Constrain Image node. I will name this group Image and Resolution. There will only be 3 nodes in this group. This node will constrain the image to a desired max or minimum resolution. It is for resizing and cropping. I will take the width and the height from the nearest SDXL node and crop it if required. To do that, convert the max width and height to input. Now, let's make the prompt and blip nodes. Search for blip and add both nodes. The blip analyze node is similar to clip interrogate from Automatic 1111. Do not change this text. When connected with an image, it will query, what does the background consist of, and get an approximate prompt from the image. We will use that instead of guessing and creating our own prompt for the loaded image. So keep this text as it is, and don't change it. This node will use the default model checkpoint from the models/blip folder, which I showed earlier. Search and add the show text node. This will be connected to the blip analyze node. If you don't do this, it will just take and pass on the prompt. However, this node will show us the prompt the blip model takes from the image. The text string node allows you to write 5 short lines of text. The prompt from the blip analyze node is not enough. We need to add some additional prompts to get the desired results. So, the prompt from the text string and the blip analyze node will be combined into one sentence. It will then pass on further. I will use the text concatenate node to combine both texts for the prompts. I am adding 3 nodes in parallel. The first one is a text multi-line node. This will be the positive prompt node, which we can edit. Whatever prompt the text concatenate gives, if we want to make changes, we use this node for it. I will explain later how this will exactly work. The second node here will be a duplicate of the show text node. It will show the prompt from the text concatenate. The third node will be a simple primitive node, which I will use for the negative prompt. The combined prompt will be passed through the SDXL prompt styler. For the pass-through, right-click and convert the text positive and negative to input. Add the final clip text encode node, which will connect to ControlNet. This node should be the SDXL version since we use the SDXL checkpoint. Except for crop width and height, convert everything to input. That's all the nodes for prompts and Blip. Let's work on the IP adapter nodes. This group will contain 4 nodes, the IP adapter apply and upscale image, the IP adapter model, and clip vision nodes. There will be 2 ControlNet models with a twist. To start, let's add the ControlNet Lora nodes. The first will be the control Lora depth, and the second will be canny. I will connect line art with canny, as there is no other compatible preprocessor for SDXL in Comfy. It works completely fine. I will use the Zoe depth model for the depth preprocessor. Add 2 ControlNet apply models and use the advanced version. Now, search for a node called Image Invert. The line art processes the image in black with white lines. That is the exact opposite of what we need. So, by connecting the Image Invert node to the preprocessor, we will get a white background with black lines. And this will be the final ControlNet image that goes to the sampler along with the IP adapter model. I will also pass this image without the ControlNet applied to the VAE encode in image generation. Let's do the image generation nodes now. Adding the VAE encode first. I did explain in a previous video the function of VAE encode versus decode and why we use them. The second node here is the repeat latent batch. This will allow you to generate in batches. This primitive node is for the sampler seed. You don't require it as you can change it from the sampler. I find it easier to edit it from a separate node. Now add the K-Sampler Advanced node and then the VAE decode. For connecting the nodes, let's start with the load image. The first thing to do is to connect it to both nodes. Both nodes serve a different purpose here. We don't want to calculate the image's width, height, or ratio every time we load any image. The SDXL resolution node takes this info and is passed to the constrain node. The SDXL node will also pass on this info to the positive and negative clip encode prompts. Whereas the constrain node will pass on the constrained width and height to the ControlNet, IP adapter, and image generation models. Next, connect the constrain node with ControlNet. I am using a reroute to split the image between both the ControlNet preprocessors. I almost forgot, before making the connection, ensure that crop, if required, is yes. Connect Zoe with the first ControlNet and add a preview node. The line art output will connect to the second ControlNet and invert image inputs. Also, add a preview node. Add a preview node for the invert image as well. Change the preprocessor's resolutions to 1024. Enable coarse and line art to get clear and sharp outlines. Connect both ControlNet outputs to the apply ControlNet inputs, respectively. The depth strength should be 0.7, and the line art should be at 0.25. You will not be required to change these values at all for the desired effect. I will let you know which values can be altered to make changes in the generation. You can see the connection flow of the image to ControlNet. Make a second connection from the image to the Blip analyzer. Also connect the Blip model output and input. Here, we do not connect the constrain node because we just need the node to analyze the original image for the prompt. Connect the Blip string to show text. Connect the show text string to text A input. Type comma, space, black and white, comma, and space again. For the text B, type colorless, comma, and space. Here, type in line art, comma, line work, and full stop. Connect in order to text inputs of B, C, and D. Connect the text concatenate to show text. This will be the positive prompt that we will connect to the prompt styler. During a live workflow example, I will show you how to edit this prompt by connecting the above positive prompt node with the prompt styler. Now, connect the negative prompt to the prompt styler. The negative keywords I use are shadows, gray fill, blurry, watermark, text, dark background, thick, color, shading, gradient, and transparency. There won't be any need to change the negative prompt as this works. Most of the things you need to eliminate from an image can be done differently. Use the negative prompt to omit elements from the generation as a last resort. For the style, select line art. The prompt styler outputs connect to the respective positive and negative text G and L inputs. To recap, the image connects to the blip, which generates the prompt. We added our prompt and combined it. The positive and the negative connect to the prompt styler, which splits to the SDXL clip encode nodes. Connect clip vision and IP adapter model to the apply IP adapter. The load image connects to the line art preprocessor, which connects to the invert image node. This output has two connections, one to the VAE encode and the other to the upscale image input in the IP adapter group. The upscale image will connect to the apply IP adapter node. The near SDXL resolution output will also connect to the SDXL clip text encode nodes. First, drag out the width and reroute. Now, do the same for the height. Take the width and make 4 connections in total to the positive and negative width and target width. Do the same for the height. Connect the model from the load checkpoint to the apply IP adapter input. Create a reroute for the VAE and connect the 2 relevant nodes in the image generation group. The model output from the IP adapter should connect to the model input in the case sampler. The image generation node's connection is simple. The VAE encode connects to the repeat latent batch. That connects to the case sampler, which further connects to the VAE decode. In the case sampler, convert the noise seed to input and connect it with the primitive node. The case sampler settings are significant to this workflow. The add noise should be enabled if you want consistency with seed. If you disable this, the same seed will produce different results. Steps: keep it at 20 and don't change it. CFG here, the default would be at 10 instead of 7 or 8. The CFG is one value you can play around with. In cases where the prompt is edited, and you want more weight to it, increase CFG. Also, note that the CFG is slightly restrained because of the ControlNet and IP adapter. The IP adapter weight plays a more prominent role than CFG. I still have to add a whole section of post-processing effects. Once those are added, you will find that CFG is basically a subtle change. Change the sampler name to Euler Ancestral. This works best for line art. The scheduler, stick to Keras. Return with leftover noise, enable it if you are adding a second sampler. I kept it enabled and tested all the images. To follow the tutorial, I suggest you keep the same setting. Connect the positive and negative clip text conditioning to the first apply ControlNet. Then, connect the first and the second apply ControlNet. And finally, connect the second ControlNet to the case sampler. Connect the model clip output to both clip text and code inputs. In the IP adapter group, the upscale image width and height should be 1024, and the crop should be centered. The image given to the IP adapter should always be SDXL resolution. Since the load image may have different aspect ratios, by this node, we are making sure that the output to the apply IP adapter is SDXL resolution. Any cropping, if done, would be centered. This, however, will not affect the output resolution of the final image. That's why I have a different node setup in the image and resolution group. The default value I have set for the IP adapter weight is 0.25. Altering this value will give you deeper blacks, more details, or vice versa. It depends on image to image. I will show some examples where I alter this value. I suggest you keep the weight type to channel penalty for line art. This method is experimental, and the results may change in the future after an update. For consistent results, go with the original weight type. The workflow is not completed. There are some pending nodes, but let's connect a save image node to test if everything works as intended. Now that everything is set, let's test the workflow with this shoe concept art. This is the final combined positive prompt. It includes the blip prompt and the text string. The first image is the depth map, the second is the line art, and the third is the inverted line art, which gives the desired results. The shoe design is spot on, but a lot of extra details were added. This is probably because of the Blip prompt. This can be fixed easily. What we need to do is remove this text from the prompt. So, select all the text, copy it, and then paste it into the positive prompt node above. Edit the prompt here and connect this string to the SDXL prompt styler and Q prompt. Okay, the candle has been removed, but some details still remain. Let's change the prompt one more time. Let's remove on a table and see what happens. By the way, add noise is enabled, and the seed is fixed. This is why I am getting consistent results. Perfect. Let's add an upscaler to the workflow. Add the Ultimate SD Upscale node. Use the same seed as the K-sampler. The CFG scale doesn't matter, since the denoise strength would be 0.3, a very low value. The sampler name and scheduler should be the same as the K-sampler. Mode type keep it linear and change the tile resolution to 1024. Connect the upscale model and choose the 4x full Hardy Ramakri. Drag the ControlNet output with the positive and negative input. Connect the VAE decode to the image input. Now, connect the model from the checkpoint to the upscaler. Finally, connect the VAE via the reroute. Rename the second save as Final Upscale. Let's hit the Q prompt and check out the upscale quality. Excellent. In this example, I am choosing a DSLR photo of a Joker Lego. I will first try the image without upscaling. To deactivate, right-click on the group and select Set Group Nodes to Never. This will deactivate all nodes in that group. As you can see, Blip picks up a lot of color in the prompt. However, I do not recommend changing the prompt to remove the color. There is a better method. There is some green. I will remove the color by adding a filter. Drag the output from Ultimate SD Upscaler and search for a node called Image Filter. The only value you need to change here is the saturation. Change it to 0. We will use this filter only to remove the color and nothing else. Let's name this final upscale black and white. The color is gone, but there is a gray shade. There is another node to remove that. Same process, but this time, search for image level adjustment. Here, the black levels will make the lines darker, and the white levels will make the whole image lighter. Values below 100 start to fade the image off, but that depends on the image. Let's try 100 and see. It did remove the gray. It's not 100% perfect, but it's very good. Let's choose a fashion design. I have included a workflow node that will randomize the seed and process images in batches. To do that, go to Repeat Latent Batch and enter the number of images you want to generate. As you can see, it has randomized the seed and generated 10 designs. This node is also useful when you don't want to fine-tune the images. For instance, while testing, some images had thick back shading in some areas. I found it beneficial to always generate in batches and fine-tune one from the batch. This workflow works with any category of images. This is one example where I fine-tune the image with multiple nodes. Let's choose an interior design. I am increasing the IP adapter weight to 0.5 to get more details. The line art for this image comes out a bit blurry in the bokeh areas. That can be fixed by increasing the edge enhancement value. Also, I want the black lines to be more prominent and the gray shading to be reduced. Notice the blurry bookshelf and the trees on the left. This is with edge enhancement. Blurry. Sharp. Less gray. Let's say you only want the subject and no background. Basically, this is just one node called Randomize, short for remove background. To only remove the background, this works out of the box for line art. The load image output should be connected to the input of this node. For this to work, you have to connect the output with the ControlNet inputs. The output should also connect to the Blip Analyze node. After the background removal, the image does not require fine-tuning. ControlNet and the IP adapter will process an outlined image. Neat and clean lines. This will also work with a photograph. Let me show you another example. Beautiful. I hope you found this tutorial helpful and learned something new in Comfy. Until next time.